Welcome to another video by Adeptis Academy. Get ready to embark on an incredible journey beyond our world. Ever wondered what it's like to travel among the stars, to witness the breathtaking beauty of distant galaxies, and to explore the mysteries of the cosmos? Today, we're diving into the world of spacecraft, the incredible vehicles that make these dreams a reality. These aren't just machines. They are marvels of engineering, the amazing machines that make space travel possible, pushing the boundaries of human exploration. These vehicles carry astronauts, brave men and women who venture into the unknown, satellites, the silent guardians of our communication and navigation systems, and robots, tireless explorers that traverse alien landscapes far beyond our planet, extending our reach and understanding of the universe, letting us explore the moon, our celestial neighbor Mars, the red planet that holds the promise of future discoveries, and even distant galaxies, unlocking the secrets of the cosmos. Imagine a car, a boat, and a plane combined, all engineered to operate in the most extreme conditions imaginable. Now make it even more special, capable of withstanding immense pressures and temperatures. That's a spacecraft, a testament to human ingenuity and technological advancement, built to travel where there are no roads, water, or air, venturing into the vast emptiness of space. It must be strong to survive launch, enduring incredible G-forces as it escapes Earth's gravity, smart to navigate space, using complex algorithms and sensors to find its way, and safe for astronauts on long journeys, providing life support and protection from the harsh environment. We'll break down the science and engineering behind these vessels, exploring the intricate systems that make them work, building our own virtual spacecraft piece by piece, understanding the function of each component. From the protective body, designed to withstand extreme temperatures and impacts, to powerful engines, generating the thrust needed to break free from Earth's gravitational pull, fuel tanks, storing the energy that powers these incredible journeys, and computer brains, the sophisticated systems that control every aspect of the mission. We'll see how every part works together in perfect harmony to achieve the impossible. By the end, you'll understand how spacecraft are built, from the initial design to the final assembly, how they fly, navigating the complexities of orbital mechanics, and why they matter for life on Earth, connecting us, informing us, and inspiring us. The science of space helps us every day, often in ways we don't even realize, from weather forecasts, providing us with crucial information about impending storms, to GPS, guiding us on our daily journeys. Let's start our journey into the exciting world of spacecraft mechanics. Prepare for liftoff. So, what exactly is a spacecraft? It's any vehicle designed to fly beyond our skies, navigating the extreme environment of space. Some carry people, brave astronauts venturing into the unknown. Others are robotic explorers, gathering data and sending it back to Earth. Satellites orbit Earth, essential infrastructure for our modern world, helping with communication and navigation. Probes travel to other planets, seeking answers about the origins of life. A spacecraft is a self-contained world, a technological marvel designed to sustain life in the vacuum of space. It keeps the temperature just right and shields its contents from the harshness of space. Whether it's a giant space station, a tiny satellite, or a Mars-bound rocket, all spacecraft share the same goal: to break free from Earth and explore the cosmos. Let's start with the spacecraft's body. We're going to explore the intricate details that ensure a spacecraft can withstand the harsh conditions of space. This foundational element is known as the structure or bus. It's the central component upon which everything else is built. It's like the frame of a car, the chassis that provides the necessary support and rigidity. Think of it as the skeleton of the spacecraft. It's responsible for holding everything together, ensuring all the critical components are securely mounted and integrated. More importantly, it's designed for withstanding the violent forces of launch. The immense vibrations and accelerations experienced during liftoff demand a robust and resilient structure. The body must be lightweight yet incredibly strong. This drives the selection of advanced materials and innovative engineering techniques. To achieve this, engineers use special alloys and carbon fiber composites. These materials offer an exceptional strength-to-weight ratio. Beyond structural integrity, it also acts as a shield, providing essential protection from the hazards of the space environment. This includes protecting against micrometeoroids and extreme temperatures. In sunlight, a spacecraft can get hotter than an oven. Conversely, in shadow, it can get colder than Antarctica. Therefore, insulation keeps the inside comfortable, regulating the internal temperature for optimal performance of onboard systems. Now, how does a spacecraft move? That's the job of its engines, or thrusters. Unlike car engines, rocket engines work in the vacuum of space by shooting gas out the back thanks to Newton's law. Every action has an equal and opposite reaction. Powerful chemical rockets launch spacecraft from Earth, mixing fuel and oxidizer to create massive thrust. Once in space, smaller thrusters called the Reaction Control System, RCS, handle turns and fine adjustments with tiny puffs of gas. For long journeys, some spacecraft use ion thrusters, which gently push ions out the back using electricity. Ion engines are slow but super efficient, perfect for deep space missions. Whether it's a fiery launch or a gentle course correction, engines are what make space travel possible. Every movement in space is carefully planned and executed. Next, let's see how spacecraft store and use their fuel. Every engine needs fuel, stored in special tanks. Think of them as the spacecraft's lunchbox. These tanks must be lightweight yet strong, holding high-energy fuels and oxidizers like liquid hydrogen and liquid oxygen at super cold temperatures. Cryogenic tanks are heavily insulated to keep everything from boiling away. In microgravity, engineers use clever tricks, like bladders or small thrusters, to make sure fuel flows to the engines. For steering, spacecraft often use hypergolic fuels that ignite instantly on contact, making them reliable for quick maneuvers. These fuels can be stored at room temperature, perfect for long missions. Fuel tanks are among the heaviest parts at launch, so rockets drop empty tanks as they climb. Now let's explore the brains behind the mission. A spacecraft needs a brain to know where to go and how to get there. That's the Guidance, Navigation, and Control System, GNC for short. Navigation uses sensors like star trackers and gyroscopes to figure out the spacecraft's position and orientation. Guidance compares the current position to the planned path, calculating any needed corrections. Control sends commands to fire engines, move solar panels, or point antennas. Spacecraft computers are built for reliability, with backups ready to take over if something fails. Near Earth, GPS helps with navigation, but deep space missions rely on star maps and onboard sensors. The GNC system is the pilot, navigator, and engineer all in one. Without it, a spacecraft would be lost in the void. Next, let's see how spacecraft fly and turn in space. 10. Flying in space is nothing like flying a plane. With almost no gravity or air, a spacecraft keeps moving unless something changes its speed or direction. Engines only fire for course changes, called burns. To travel between planets, scientists use clever orbits, like the Hohmann transfer, to save fuel by coasting most of the way. It's like aiming for where a moving target will be, not where it is now. Turning in space uses RCS thrusters, firing tiny puffs of gas to rotate the spacecraft. For big stations like the ISS, control moment gyroscopes, CMGs, spin and tilt to turn the station without using fuel. Gyroscopes create torque, letting the spacecraft pivot smoothly. Every move is a careful balance of physics and engineering. Spacecraft must be precise. There's no room for error millions of miles from home. For crewed spacecraft, being a home is as important as being a vehicle. The life support system provides air, removes carbon dioxide, and recycles water, even from breath and sweat. On the ISS, advanced purification makes recycled water cleaner than most tap water on Earth. Microgravity is fun, but tough on the body, so astronauts exercise daily with special machines to stay healthy. Living in space means adapting to weightlessness, from eating to sleeping. Astronauts conduct experiments, maintain the spacecraft, and sometimes venture outside for spacewalks. Research in microgravity leads to new discoveries and technologies for Earth. Every day in space is a mix of science, teamwork, and adventure. Astronauts turn a spacecraft into a hub of human activity and discovery. Why do we build spacecraft? For discovery, for technology, and for our future. Spacecraft are our eyes and ears in the cosmos, sending back images and data that answer humanity's biggest questions. Technology developed for space leads to everyday inventions: memory foam, scratch-resistant lenses, cordless tools, and more. Water purification systems from the ISS now help provide clean water on Earth. Satellites monitor weather, track climate change, and help us manage resources. From space, we see Earth as one interconnected system, a fragile, beautiful home. Exploring space pushes our technology and imagination further. One day we may build bases on the moon or send people to Mars, ensuring humanity's survival. Spacecraft are more than machines. They're symbols of our curiosity and our drive to reach for the stars. They carry the human spirit into the future. The adventure is just beginning.